There's not much to do in Antarctica except scientific work. You could check out the wildlife, like some cute penguins and seals. And you'd get to see the occasional whale swimming around. Antarctica is one of the biggest lands out there that's only inhabited by scientists and researchers from all over the world. These scientists dug a hole through some pretty thick ice to study the ancient air and how the atmosphere cleans itself. They used a special drill and dug a clean cylindrical hole 450 feet below the surface. Some of this ice can be up to 800,000 years old and is a good indicator of what the climate was like in the past. It's like checking out tree rings to determine how old a certain tree is, except it's more complicated than that. After the effortless digging, they decided to drop some ice to the bottom of the hole to see what would happen next. They heard some really unusual sounds. It felt like being on a spaceship traveling through a bunch of obstacles with many rocks smashing into each other. The pitches changed over the quick descent of the block of ice, ranging from high pitch and ending with a low heartbeat-like sound. The scientists were puzzled when they first heard this and dropped some more ice, only to find out that the same type of sounds were being produced, just in different variations. They couldn't tell what was down there and, more importantly, why these kinds of sounds were produced. Antarctica boasts quite a few volcanoes, many of which are under super thick sheets of ice. Scientists discovered 91 volcanoes and claimed there could be more, potentially making it the most extensive volcanic region in the world. While they were doing regular scientific research, they came across many unmistakable large cone-shaped figures underground. Some were as deep as 2 miles in the ice. Some of the peaks were over 3,000 feet tall and dozens of miles across. But on the surface, it's as plain as a sheet of paper. They may have dropped that block of ice inside an actual volcano that they were standing on, but it's unlikely. Even though the underground volcano presence was discovered by accident, there's a small chance they were actually standing on one where they had their workstation set up. It's more likely that they worked in an area where studying ancient climates is easier and less dangerous than other places. They collect ice samples and study them in a lab. It's like discovering a prehistoric insect embedded in amber millions of years ago when dinosaurs used to roam the land. But instead of little bugs, scientists study ancient dust, air bubbles, sea salts, volcanic ash, and anything else that may have come from the environment. They can practically tell how the climate was during that time. These ice samples might show that Antarctica's western ice sheet melted when the Earth's climate warmed up. If it did, then it's likely to happen again. That would mean sea levels rising, affecting coastal cities and small remote islands. But scientists aren't sure it's true, despite some evidence to back it up. The process of studying ice samples can take a week or even a year, depending on what they find. They crush or melt the sample bit by bit. And like those tree rings, the deeper the layer, the further we go back in time. In order to study ancient bubbles trapped in ice, researchers have to crush the samples under a vacuum hood to keep the air out while extracting the air and putting it in vials. There are various instruments and devices to study the ice samples, but because it's so sensitive to damage, each measurement must be in a clean room setting so that nothing gets compromised. The scientists have to wear proper bodysuits and many layers of gloves and constantly get ventilated. Even something as tiny and insignificant as a fingerprint can ruin a sample. They look for certain patterns to see changes in the atmosphere's composition and temperature. But dropping a few blocks of ice down a hole wouldn't be so bad. The reason why it made such a peculiar sound is the same reason why a moving car sounds different when it's honking than when it's stationary. The scientific word for it is the Doppler effect. It's an obvious change in the frequency of a wave with respect to an observer who is moving relative to the wave source. The effect doesn't mean the frequency of the sound changes, it just shifts. And this can be said about other types of waves, like water and light. But sound waves are the most popular ones when it comes to the Doppler effect. So, when the scientists dropped the ice block down the bottom of the hole, the sound waves traveled back up and bounced around the narrow tube where they drilled. That's why they got the pew pew sound. Let's not forget that this ice block traveled 450 feet beneath us. Oil ships dig holes in the oceanic crust that go thousands of feet beneath the Earth. The Kola Super Deep Borehole in Russia is the deepest hole ever made by humans. It goes more than 40,000 feet below the surface and took almost 20 years to reach 7.5 miles. Below it is only half the distance to the mantle. In terms of the whole Earth, this very deep hole is literally scratching the surface. This wasn't a hole to dig for oil, and wasn't in the ocean either. The drilling was stopped in 1992 when the engineers found out that the temperatures were 100 degrees Fahrenheit higher than they predicted. And then it was abandoned, and it's just been a barren hole now. But that's the closest we've dug to the center of the planet. The scary thing is that some of the workers on the site could hear voices coming from within. All the way in Yemen, an ancient hole exists in Barhout, in the east of the country in the middle of the desert. It's actually closer to Oman than to the capital Sana'a. This hole has puzzled experts and locals. Unlike the holes in Russia and Antarctica, this wasn't man-made. Or was it? It's been around for many years, and the locals try to steer away from it. They don't even like talking about it, since they claim it brings bad luck to those around it, or to whoever utters its name. They claim it was created as a prison for spirits, but many rule that out. The hole is 98 feet wide and somewhere between 330 to 650 feet deep. You can also hear strange sounds coming from the inside. But according to some scientists, the well has little to no ventilation and barely has any oxygen down there. So it's unlikely that anyone or anything lives down there. The Challenger Deep in the Mariana Trench caught some low-pitched grumble sounds in March of 2016. Some of these grumbles were followed by screeches. They caught these sounds in a span of weeks, using a titanium-encased microphone so that the immense pressure of the lowest point on Earth wouldn't crush it. They had to lower it slowly as well, since it's 1,000 times the atmospheric pressure at sea level. For 23 whole days, the microphone recorded typical sounds of whales passing by and boats sailing across from above, and even rumbles of nearby earthquakes, but they still couldn't determine what caused those initial sounds. The researchers couldn't understand if the noise from the bottom of the Mariana Trench was caused by humans or was natural. They also wanted to know if these sounds affected marine life, like dolphins and whales that rely on echolocation. They still can't figure it out, but scientists estimate that the ocean is about 10 times noisier than it was 50 years ago. With technological developments in shipping, submarines, and underwater construction, the ocean will only get louder with time. Northern lights come with sounds, which nobody talks about. They're usually audible when the auroras are at their most powerful presence. Scientists were always puzzled as to what caused the faint popping and crackling, even though they were very far above us. They used some special microphones and found out that the sounds came just 230 feet above us, which is pretty low. They're caused by electrical charges gaining power in a specific region of the auroras. The electrical charges are disturbed by magnetic storms that fire up the northern lights. As a result, some tiny sparks are released into the atmosphere, causing the faint crackling and popping noise. The Earth has three main layers: two parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon, and made of nickel and solid iron. It's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, A team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
It was one of the biggest creatures ever to roam the Earth. It was longer than your average school bus and could easily weigh more than 10 elephants combined. But where did it live? How did it end up having this size? And most importantly, why is it extinct nowadays? Let's find out. The megalodon was the largest predator ever known in our planet's history. In terms of its location, the megalodon lived practically in all waters on our globe, except near the poles. The reason why there were no megalodon teeth found in Antarctica is probably that the gigantic creature adapted to only warm tropical and subtropical waters. The younger ones liked to keep to the shores, while full-grown adults preferred coastal areas, but they could easily move into the open ocean as well. How do we know the megalodon was so widely spread? We can only presume, based on the fact that they discovered the most northern fossils off the coast of Denmark and the most southern in New Zealand. The discussion of how the megalodon got this size is still open in the scientific community. They recently found out that not all the specimens from this fascinating species reach the same huge size. This has to do with a little something called the Bergmann's Rule, which says that the temperature of the surrounding environment affects the animal's body size because they either need to conserve or shed heat. The megalodons that reach cooler waters probably needed more body weight to make sure they survived in low temperatures. On the contrary, those living in warmer waters had to be smaller to avoid burning up. But what did this enormous fish look like? Most modern depictions show the megalodon resembling an enormous great white shark. But well, it seems it may not necessarily be correct. The megalodon likely had a much shorter nose and a flatter jaw that looked almost squashed when compared with a great white shark. It also seems to have something in common with the modern blue shark: extra long pectoral fins. They needed these to support their weight and size while navigating the planet's waters. Lastly, the lady megalodons, seem to have been about twice as large as the gentlemen. As for their offspring, even a small megalodon was enormous, at least 6.5 feet from nose to tail. How do we know that? Because specialists have stumbled upon megalodon nursery habitats in Panama, Maryland, the Canary Islands, and Florida. Even the piles of used diapers were enormous. Nah, not really. Surely the scariest aspect of the megalodon's looks was its mouth. I mean, think about it. Megalodon had whales for dinner, so it obviously needed to open its mouth wide enough. Scientists have estimated that its jaw would span a mind-boggling size, 9 by 11 feet wide. Just to paint you a better picture, that means it could have easily gulped down 2 adult people side by side. Wait, which 2 adults? Those impressive jaws also feature 276 teeth. Based on modern reconstructions of the force of its bite, it looks like it may have been one of the most, if not the most, powerful animals of prey ever to exist. For comparison, humans can have a bite force of around 1,300 newtons. Today, great white sharks have been estimated to be able to bite down with a force of over 18,000 newtons. The megalodon tops all the records, with an estimated power of bite up to 10 times greater than that. It could basically crush a car with very little effort. Its teeth were also pretty amazing. Similar to sharks, the megalodon was fast in replacing its broken or worn teeth. With 4 or 5 rows of teeth in its mouth, it basically acted like a conveyor belt, growing back damaged or missing teeth within about 48 hours. This means that an adult megalodon probably would have grown several thousand teeth throughout its lifetime. It was nice of them to do that, though, since it's probably one of the reasons why megalodon teeth are so common in fossil records, and we're able to study them properly. To maintain its impressive physique, the megalodon had to eat somewhere around 2,500 pounds of food per day. Can't wrap your head around that? Well, it was the equivalent of 1.25 cows per day to survive. It's like if you had to eat 3,300 cans of tuna every day. I've used the word megalodon a lot, but have I mentioned where it comes from? When translated from Greek, it means giant tooth. Ah, those clever Greeks. However, this giant shark's full scientific name is a bit more complicated: Carcharocles megalodon. But are these gigantic predators actually extinct? We tend to believe so, but let's be honest for a second. We've come to know more about the surface of Mars than the depths of our oceans. Like, we've only explored 15% of our oceans altogether. Who knows what may be lying out there in the deep? Maybe some ancient predators? The Mariana Trench is the deepest oceanic trench on Earth. The Challenger Deep, its deepest part, is so deep that you could dip the whole of Mount Everest in there and it would still be over a mile above the surface. That's deep. If a megalodon or two ever needed a place to crash, that would be a discreet enough location. However, the Mariana Trench is not a particularly comfy place to be in. Because it's cold and steeped in total darkness and all. The temperatures here are around 36 degrees Fahrenheit all year round. And to top it all off, the pressure is 1,000 times stronger than at sea level. So it's safe to assume that if any megalodon is hiding in here, its teeth and bones might not be looking so good. Because of the intense pressure here in the Mariana Trench, proteins and calcium start to dissolve and disintegrate. That's why, for example, the Haddell snailfish, the deepest dwelling fish we've discovered, has evolved to feature flexible cartilage instead of bones. To survive here, the megalodon would also need to learn to navigate in complete darkness. That means it would have to either become luminescent or evolve to grow massive eyes like the giant squid. While it may sound like an intriguing and good idea for a movie script, most scientists don't think it's possible. Why? Well, most of them say it's because of the megalodon's size. Most foods that megalodons like to eat live in shallow ocean areas and not in the deep, deep sea. Specialists believe that if these animals were actually still roaming our waters, there's no way we wouldn't know about it. They would need to come up for dinner every now and then, right? Their food is also the most likely cause of why the megalodon is not alive anymore. While some specialists believe the megalodon became extinct because of a drop in the ocean water temperature. Most scientists suggested that the shifting food chain dynamics may have been more to blame. Why? Because at some point, there was less and less of its primary food source, baleen whales, and at the same time, the numbers of its natural competitors, like smaller predatory sharks like the great white shark and whales, increased. The megalodon did live on this planet a lot more than we did, and way back when we didn't even exist yet. They were here for nearly 70 times longer than we, modern humans, have, inhabiting the oceans for around 20 million years. Homo sapiens appeared around 300,000 years ago. The megalodon managed to survive for so long mostly because of its unbeatable size. I mean, they can make a meal out of almost everything in the sea at the time. We may think about both of them as prehistoric creatures, but the megalodons and the dinosaurs never coexisted on Earth. The dinosaurs probably died out about 66 million years ago. Megalodons seem to have appeared a bit later. That's because the oldest megalodon fossils we have yet discovered are from the Miocene epoch, which began 23 million years ago. So long, Meg! It happened in Iceland on Friday, March 19, 2021 at 8:45 p.m. About 20 miles southwest of the capital. Molten rock suddenly burst through the surface from below. Bright lava fountains then lit up the night sky. A volcano in this valley finally woke up after almost 800 years of sleeping soundly. We divide volcanoes into three categories: active, dormant, or extinct. Around 1,900 of them around the globe are considered active. That means they've erupted in the recent past and will likely do it again in the possible near future. Dormant volcanoes haven't popped off for a long time, but they still may in the future. You could say they're sort of sleeping. As for extinct ones, those guys haven't done anything in more than 1 million years. The eruption in Iceland wasn't super explosive, and this all happened 6 miles from the nearest town, so everyone was perfectly safe. Many even came to see it up close, while other brave visitors tried to fry eggs and bacon on the lava. Just be careful not to burn your breakfast black. Lava can be over 2,000 degrees Fahrenheit. It burns everything in its path. Yet it also produces some of the most fertile land for agriculture. This eruption gave a relatively small amount of lava at first, but it's been spreading across the valley in different directions, forming a sort of shield that's constantly growing. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can ooze slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous thing about volcanoes. That would be the toxic gases spewing from the eruption. And those spread faster and further than the lava flow. Luckily, in Iceland's case, the wind has been blowing these gases away from residential areas. Scientists weren't surprised this volcano erupted. They knew it was coming. Increasingly stronger earthquakes had been shaking this area for the past 15 months. There were 50,000 earthquakes within just the 3 weeks leading up to the eruption. That's 100 per hour. The volcano has been active since March, and geologists say this could last for weeks, months, years, or even decades of constant eruptions in the area. Mount Shasta is in the top 5 most dangerous volcanoes in the U.S., so geologists are keeping a close eye on it. The last eruption was in 1250. I wasn't around then, but this volcano erupts every 600 to 800 years. Which means, tick-tock, we're due any day now. About an hour from Portland, Oregon, there's an active volcano that last erupted in the 19th century. Next time it goes off, scientists think it'll produce larger amounts of ash and dust. This could cause an electrical blackout and make water unsafe to drink in the area. But the experts pay close attention to Mount Hood. They'll be able to give plenty of warning so people can react in time. Kilauea is one of the most active volcanoes in the world. It's been erupting almost constantly since 1983, making it also one of the longest eruptions known on Earth. It's the youngest land volcano in Hawaii. Volcanoes can take thousands of years to form, but others can pop up practically overnight. A volcano in Mexico just erupted in an open field in 1943 and started growing from there. Within a year, it was almost 1,500 feet tall. When the eruptions finally stopped 9 years later, the mount had reached a height of over 9,200 feet. Mount Fuji is an iconic symbol of Japan. The last time it erupted was in 1707, and it sent a shower of burning rocks as far as 60 miles away. If a similar eruption happened today, Tokyo would be within that vicinity. Mount Fuji is right on the Ring of Fire, that horseshoe-shaped region in the Pacific Ocean full of active volcanoes and earthquakes. From one end to the other, it's almost 25,000 miles long. It could wrap all the way around the Earth's equator. In January 2020, Taal volcano in the Philippines started spewing lava, sending huge plumes of ash half a mile up into the sky. The eruption even triggered a rare phenomenon, a dirty thunderstorm. That's when the smoke cloud above a volcano produces its own lightning. The chance of volcanic tsunamis was also high. Those are usually caused by tectonic movements that occur because of volcanic activity. Taal has erupted more than 30 times in the last 450 years. This volcano in Ecuador last erupted in 2016. Scientists think it might be showing some early warning signs of magma on the move. This is an active stratovolcano, a specific cone-shaped type with steep sides. They form from sticky lava that doesn't flow that easily. That lava goes around the vent, cooling and piling on itself to form these steep walls. These types are more likely to produce explosive eruptions like the ones we see in movies. Ruapehu is the oldest national park in New Zealand, a volcanic wonderland where you can closely see all those steaming craters, magnificent lakes, and unusual rock formations. It last erupted in 2007 and has had 10 eruptions since the mid-19th century. But eruptions, lava flows, and toxic gases aren't the only danger coming from volcanoes. There's also a thing called lahar, a kind of volcanic mud flow of debris. In between eruptions, snow melts and a lake forms in the caldera. If the last eruption brought mud, ash, and rocks in the lake, it becomes dangerously full. In that case, only a temporary dam holds it back. Indonesia has the biggest number of active volcanoes in the world, including one called Anak Krakatoa. It means child of Krakatoa, and its famous parent isn't far away. A huge tsunami in 2018 partially woke Junior, a scary thought since Senior had one of the most powerful eruptions ever seen on this planet in 1883. Krakatoa's boom was the loudest sound ever heard. People over 2,000 miles away could hear the explosion. The sound wave circled the globe 7 times, and scientists say it's hard to predict this volcano's eruption patterns. Mount Yasur in Vanuatu is one of just a few volcanoes in the world where you can see a lava lake. Tourists even go there to peer over the edge and get a look at the burning, bubbling lake below. Well, except for when the volcanic activity goes to levels 3 and 4 out of 5. That means there are more intense earthquakes, volcanic tremors, or steam, gas, or ash ejections. Then this place is off limits because, duh. This volcano in the DR Congo has the most active and largest lake volcano in the world. And all that lava is unusually fluid, meaning it travels faster and further than the stuff coming out of most volcanoes. It's certainly not amongst the tallest ones, but Ethiopia's Erta Ali is unique in that it has a lava lake almost constantly, which is pretty rare. The locals call it a smoking mountain because its lava lake often causes eruptions. This volcano is near the Danakil Depression, one of the hottest places on our planet. Merupi has been erupting on a regular basis since the mid-16th century. This volcano helps scientists do crucial research on how eruptions work and how they can warn people in time. After it was dormant for a while, this volcano in central Mexico sprang back to life in 1994. Ever since then, it's been producing huge mud flows and strong explosions in unpredictable intervals. In the past, enormous eruptions coming from this giant buried entire cities in pyramids. Imagine staying in a hotel and waking up to the magnificent view of a massive volcano covered in glowing rivers of lava and clouds of ash. When it lets off heat, visitors to this area in Guatemala take a chance to roast some marshmallows there. One of the most active volcanoes on Earth is on a small island north of Sicily. Stromboli has regular explosions, together with glowing lava coming from vents inside the crater. Not too far away is Etna, Europe's most active volcano and one of the biggest continental ones in the world. By the way, Earth definitely isn't the only planet with volcanoes. The largest one in our solar system is on Mars. It would cover the entire state of Arizona, and it rises nearly 3 times higher than Mount Everest. Ooh, don't look down.
In November 1922, a boy walked through the desert mountains of Egypt and discovered some ancient steps carved into the rock. Subsequently, this find became one of the world's largest and most significant archaeological discoveries. This step was part of Tutankhamun's untouched tomb. Archaeologists found about 5,000 ancient objects, including jewelry, fabrics, painted vases, and funeral masks. You've probably seen one of them. It has become one of the most recognizable attributes of ancient Egypt. More than 100 years have passed since then, and now humanity has finally become close to another large-scale discovery, the tomb of Cleopatra. This queen was the last active ruler of the Ptolemaic Kingdom of Egypt, who sat on the throne from 51 to 30 BCE. There are many ancient records about Cleopatra, her reign, and her unusual personality, but until now, no one has discovered the secrets about her passing away in the burial place. So, one archaeologist, Dr. Kathleen Martinez, has been studying ancient records and temples around Alexandria for decades, and concluded that the tomb of the queen should be located under the ancient city of Taposiris Magna, founded in 280 BCE. It was a big city on the northern coast of Egypt, where tens of thousands of people were engaged in trade and industry, and it seems that Dr. Martinez's guesses turned out to be correct. She and a group of archaeologists have discovered a secret underground tunnel near Alexandria, with a length of about 0.8 miles. It was cut into the rock under Taposiris Magna's temple. During further excavations, they found many things that indicate Cleopatra's tomb lies in the tunnel's depths. It's also possible that she is buried there together with the Roman commander, Mark Antony. According to ancient records, Cleopatra and Mark Antony loved each other and together opposed the Roman Senate, which declared Antony a traitor. The fact that natural disasters have occurred on the territory of Taposiris Magna for thousands of years can complicate the excavations. Earthquakes and floods destroyed the city and possibly flooded its underground tunnels. But archaeologists hope the ancient tomb remains untouched, and that it hides many treasures and records about the royal life of ancient Egypt during the reign of the last dynasty. There's a chance that excavations will go underwater and in the mud. This will require much time and funding, but archaeologists are sure it's worth it. Anyway, it's too early to say that Cleopatra is really buried there, but scientists have found many things in the tunnel that confirm this, including clay pots, dozens of coins with the image of Cleopatra and Alexander the Great, as well as a bust with the image of the Egyptian queen. Cleopatra is still one of the most popular personalities in Egypt, on an equal footing with Ramesses III and Tutankhamun. She inspired many films, paintings, and books, but what made her so popular? She became famous for her inconsistency. She was a beautiful, intelligent ruler who pulled Egypt out of the crisis and made it a prosperous power. Medieval Arabic texts say she knew chemistry, mathematics, and philosophy, and may have written several scientific books. She knew several languages and had excellent diplomatic skills. At the same time, there are many legends that she was a femme fatale who drove many men crazy. However, there's no evidence that her beauty was incomparable. The image of a stunning model was created by Hollywood when it made several films where famous actresses performed the role of Cleopatra. And the Roman Emperor Octavian, the adopted son of Julius Caesar, specially created the image of Cleopatra as an insidious seductress because he was her enemy. Even though she was born in Egypt, Cleopatra wasn't an Egyptian. Her ancestors were Greeks, among whom was one of the generals of Alexander the Great. However, the people of Egypt loved her. She learned the language and was very sensitive to the traditions of this country. She knew the history, mentality, and customs of ancient Egypt well. She raised the level of its economy and strengthened its status as a world power. Much of this was made possible thanks to her cunning and impressiveness. She loved theatrical performances and lavish celebrations. She knew how to surprise people and put on a show. But behind the exterior image of a luxury lover was an intelligent and calculating ruler. Ancient Egypt was a rich, luxurious country, and Cleopatra did everything to increase its wealth and strengthen its position in the international arena. For example, she was once in conflict with her brother Ptolemy XIII. The queen knew that she wouldn't be able to resist him, so she decided to attract Julius Caesar to their side. The Roman emperor arrived in Alexandria, where Cleopatra wanted to meet him, but Ptolemy knew about her plans and was about to prevent her from coming to Caesar. Then, instead of a rich and noisy arrival, Cleopatra decided to make her visit inconspicuous. She wrapped herself in a carpet or linen bag the emperor's servants carried into Caesar's private chambers. Cleopatra emerged from the carpet and impressed the Roman emperor with her beauty and determination. As a result, they fell in love with each other and became close allies. After some time, she impressed another influential Roman for diplomatic purposes. She arrived to meet Mark Antony on a golden barge with purple sails and silver oars. Cleopatra was dressed in the image of Aphrodite and sat under a magnificent canopy. Her servants dressed like cupids and were blowing her fan and burning incense. But Cleopatra created such a show for a reason. She knew that Antony revered Greek mythology and considered himself the embodiment of Dionysus. As a result, he was so impressed with this woman that he ended up marrying her. Cleopatra defended her crown, strengthened her alliance with Rome, and bore Antony 3 children. In Egypt, they threw big parties and enjoyed wealth with power. However, the relationship of a high-ranking official with the Egyptian queen caused a scandal in Rome. Octavian was Antony's primary opponent in the struggle for power, so he exploited the situation to darken the competitor's reputation. He used propaganda to make Cleopatra an insidious seductress in the eyes of Roman citizens. He accused Antony of succumbing to her charms. The Roman Senate supported Octavian and declared Cleopatra an enemy. In 33 BCE, this conflict reached a high point when Antony's navy clashed with Octavian's fleet. The latter won and forced his enemy to flee to Egypt with Cleopatra. According to some records, they took refuge near Alexandria. Pursued by the Romans, they hid in one of Cleopatra's palaces and met their end. Some legends say that Cleopatra was an expert in poisons. She provoked a venomous snake, a viper or an Egyptian cobra, to bite her. Also, according to another legend, she pricked herself with a poisonous needle. There's a theory that Cleopatra always carried an ampule with poison inside her hairbrush. And when she was cornered, she soaked the needle with this poison and pricked herself. None of this can be said for sure. Scientists are still trying to find out the truth. Perhaps when they reach Cleopatra's tomb, the world will get more answers about her tragic fate. She is considered the last ruler of Egypt. After her passing, Octavian plundered her palaces and temples and returned to Rome, where he became the main emperor. He successfully ruled the country and expanded its borders. His reign ended when he turned 75. World history would have looked different if Cleopatra and Mark Antony hadn't lost that naval battle. By the way, did you know that more time has passed between Cleopatra's reign and Neil Armstrong's flight to the moon than between the reign of the Egyptian queen and the construction of the Great Pyramid of Giza? Armstrong took a step on the Earth satellite in 1969, 38 years after the birth of Cleopatra. and the construction of the pyramid took place in 2560 BCE. Imagine how long the history of ancient Egypt is. Cleopatra is closer to us in time than to the pyramids.
It's winter 1980. We're in the small town of Lengby. 19-year-old Jean Hilliard is driving home after meeting with a friend. She takes a shortcut and turns into an icy, slippery road. In the dark, she loses control of the rear-wheel drive car. The vehicle crashes into a ditch. Emergency lights, snowfall, night, and a hard frost. Jean gets out of the vehicle. She's wearing only a light winter coat, mittens, and cowboy boots. The air temperature is much lower than in a freezer. Jean is sure that her friend lives nearby, so she goes that way. She climbs a high hill and realizes she's taken the wrong route. It seems she's gotten lost. The girl wanders a couple more miles and notices her other friend's house in the distance. Freezing, she walks there. Then everything turns black. Jean loses consciousness. The next morning, rancher Wally Nelson wakes up in a great mood. It's the holiday season. There's a winter fairy tale outside the window. He leaves his house and notices the body of Jean Hilliard lying just a few feet from his porch. Wally approaches the girl, shakes her, and is horrified. Her body is stiff and cold like frozen wood. Her eyes are open and don't move. Her hair is frozen. She just doesn't look alive. But Wally sees that she's still breathing. Jean has managed to survive. Wally wants to put her in his car to bring her to the doctor, but the girl's body doesn't bend and can't fit into the auto. It feels like a statue. He takes a bigger car and rushes to the hospital as fast as possible. The doctors take Jean, but they don't think she has any chance to make it. Her hand is so hard and frozen that no needle can penetrate it. A low temperature, glassy eyes, and muscles as hard as stone are all the results of emergency mode. Her body has directed all the blood to the vital organs to ensure their functioning. That's why other parts of her body look so lifeless, and her skin and muscles don't react to anything. The doctors decide to put heating pads on the girl to warm her up. Her family hopes for her recovery, but right now, all they can do is just wait. Frostbite is so dangerous because all that frozen liquid begins to expand. Fill a small bottle with water and put it in the freezer for a few hours. Then take it out, and you'll see that the bottle seems to have expanded or even cracked because of the increased volume of the liquid. The same thing happens inside our bodies. We consist of almost 70% water. When it freezes, its particles turn into ice crystals and tear cell membranes. Ice fragments can stretch and destroy tissue. This is called frostbite. Also, our body can slow down all internal processes in extreme cold conditions to save strength and energy. The heart makes fewer beats, and the lungs stop consuming lots of oxygen. Metabolism slows down. It happened with Jean, and perhaps it is what saved her life that day. She was lying in the snow in severe frost for about 6 hours. But why didn't the ice particles start destroying her cell membranes? How did her body withstand such damage and manage to survive? Back at the hospital, doctors are happy to watch Jean get better. Warm blood spreads through the frozen vessels and brings her body back to life. Surprisingly, ice crystals haven't damaged her muscles and skin. A few hours later, the girl regains consciousness. By noon, she starts talking. Jean doesn't know what happened. She remembers walking to her friend's house and then waking up in the hospital. What worries her most right now is that her father's car is somewhere in a ditch. As it turns out, the girl fell down and crawled on all fours to Wally Nelson's house. She doesn't remember it, But apparently, her brain activated the survival instinct that night. Unfortunately, she didn't manage to crawl the last few feet. Jean passed out at the door and stayed there for 6 hours. Doctors examine the girl and understand that she's completely healthy. Soon, she's discharged from the hospital. This case isn't unique. One professor of emergency medicine, David Plummer, said he'd seen about 12 similar cases over the past 10 years when patients had survived severe frostbite. Jean returns home and finds out that she has become famous. People write about her in newspapers, want to interview her, and film documentary shows. Her case has attracted the attention of many doctors around the world, but no one has been able to find out exactly how she managed to survive. In the case of humans, such recoveries seem like an absolute miracle. But many creatures of the natural world can adapt their bodies to extreme conditions. One of them is the tree frog. These animals live mainly in temperate and tropical parts of Eurasia. Sometimes they have to contend with cold weather. Their body injects glucose into the bloodstream when they feel they're freezing, and the content of their cells turns into syrup. Sugar lowers the freezing point of water. So, tree frogs have adapted to such conditions. The water outside their cells can freeze. Their bodies can get as hard as ice cubes, but they will be alive, feeling great. Then, when it gets warmer, they fully recover. The blood fills their body and puts all their muscles in motion. But one of the most amazing animals that can withstand freezing temperatures is the ghoulish icefish. It's transparent and somewhat like a jellyfish. It swims in the dark, cold Antarctic waters. The ghoulish icefish feels comfortable there because of the antifreeze in its body. More precisely, it's a unique substance that is like antifreeze in its functions. This liquid doesn't allow the animal's cells, organs, and the whole body to freeze. There are no red blood cells in the fish's blood that transport oxygen throughout its body. This is the only vertebrate with such a superpower. There are organisms on our planet that use the cold to prolong their life. Scientists have found some of them in the ice of Siberia. Those are microscopic, multi-celled creatures, like small worms, that can live in a freezer for about 10 years. But the worms from Siberia were about 24,000 years old. The scientists transported them to the laboratory and thawed them. The worms came to life and began to multiply immediately after all those centuries of sleep. Their bodies can go into cryptobiosis. This is when an entire frozen organism has minimal vital functions. The analysis showed that the worms could stay in this mode for tens of thousands of years. And there are many such animals on our planet. Also, these creatures are some of the world's most resistant to radiation. They are practically invulnerable. Now back to our story. It's possible that Jean Hilliard's body went into short cryptobiosis. Perhaps there was some non-freezing liquid in the girl's blood, but no one knows for sure. These days, she has an ordinary job and almost doesn't remember that day. Further research on this topic can help scientists create special medicines that can help in freezing temperatures. Just imagine that you could safely go outside in the winter wearing a t-shirt and a pair of shorts. Steam would be coming off your body, and the ice under your feet would be melting. You'd feel hot inside. A dream, perhaps. But realistically, winter coat manufacturers would, of course, never allow it. Meteorites rain down on Earth every single year. Almost 63% of the 69,268 meteorites scientists have officially recorded in the Meteoritical Bulletin database have been picked up from a polar desert. From where? Antarctica. It's technically a desert because it gets little precipitation. The continent receives an average equivalent of about 6 inches of water annually, mostly from snow. The interior parts are even drier. Not much action happens to meteorites there. Deserts are like safe storage closets for them, and it's easier to spot meteorites there. In total, there are around 42,000 meteorites in Antarctica. Most of them have been spotted since 1976. The Sahara Desert in Africa isn't far behind. Nomads and treasure hunters have discovered over 14,000 meteorites there, especially since 1995. Then there's the Arabian Peninsula, mainly Oman, where they've unearthed about 4,200 meteorites. So why does Antarctica take the crown for its meteorite collection compared to other areas? It's not because more meteorites land there. Statistically, they can land anywhere. Antarctica wins because it's great at showing off these space rocks. The icy environment keeps them in mint condition. The contrast between the ice and space rocks makes spotting meteorites easy. Plus, there are spots called meteorite stranding zones, where the geology, ice flow, and climate team up to gather meteorites. Here's the sci-fi part. Satellites help researchers find meteorites. They use these space gadgets to spot the best places to search. Some of these meteorites are ancient, like 1 million years old. Now, when you think about how many meteorites there are, it's a bit like a pie chart. If you measure their weight instead of just counting them, things get interesting. Antarctica's slice of the pie gets smaller. On average, an Antarctic meteorite weighs about 2 ounces, like a small bar of chocolate. Ooh, chocolate. But in the Sahara, they've got all sizes, so the average is about a pound. Now let's talk about meteorites in action. Only a tiny bit, maybe just 1.8% of all meteorites found have been seen falling. These are called falls. Clever name. Meteorite detectives, or meteoriticists, get all excited when they see that. The other 98% are finds. Someone stumbled upon them without seeing the meteorite take its cosmic leap. So when we only look at the ones that fell from the sky, most are called stony meteorites. These are like regular fellas of the meteorite world, but there's also a special kind called iron meteorites, or just irons. There are also super rare meteorites, called mesositerites, and pelocities, that are like a mix of metal and regular rock stuff. In places where humans live, like North America, people tend to find more iron meteorites than those that fell. That's because iron ones are usually bigger and more eye-catching. Farmers found some of these while they were working in their fields. Oh, surprise! A bunch of gigantic iron meteorites from places like China, Namibia, and the US make the chart slices huge. Now, check out this adventure. A group of scientists braving the crazy cold of Antarctica's icy desert to uncover some fresh meteorites found what they had been looking for. In fact, one of the meteorites weighed almost 17 pounds. The ones like that are pretty huge. Do they have an impact on Earth? Science says yes, they do. Meteorite impacts are more common than you think. About 17 meteorites smack Earth's surface every single day. Since most of the planet is covered with water, there are loads of places without people around. That's why these hits often go unnoticed. Most meteorites are just small bits zipping through our atmosphere anyway. By the time they touch down, they get tiny thanks to all the friction against the air. Not all meteorite impacts are wimpy. Some supersized ones have rocked our world. Remember when dinosaurs said bye-bye? Yeah, that might have been the fault of a huge asteroid. These meteorite hits are random, and they happen all the time. Scientists have uncovered evidence of a massive meteor impact even before the famous dinosaur wipeout. This impact is thought to have triggered the biggest extinction event in Earth's history. The 300-mile-wide impact crater is chilling over a mile beneath the East Antarctic ice sheet. This mega event occurred about 250 million years ago. The epicenter of the crater is in the Wilkes Land area of East Antarctica. It might have started the breakup of the Gondwana supercontinent. It was a big landmass that included parts of what are now South America, Africa, Antarctica, Australia, and more. So, the Gondwana supercontinent started to chip off by creating a tectonic rift that pushed Australia northward. This Wilkes Land impact surpasses the one that led to the dinosaurs' extinction in terms of scale and could have caused catastrophic consequences at the time. The Hoba meteorite is a huge chunk of space stuff chilling on Earth. It crash-landed about 80,000 years ago in Namibia. The thing is a heavyweight, like twice the size of the next biggest meteorite ever found. Interestingly, it also has a weird flat shape. Nobody's moved it since it fell, so we really don't know how deep it's hidden. But experts think it skidded along ground like a stone skipping on a lake because it landed at an angle. That's why it didn't leave a big crater when it hit the ground. And it was discovered by chance. A farmer found the world's biggest single meteorite. He was plowing his field with an ox and a regular plow. Suddenly, he heard a scraping noise. It was the metal plow meeting the iron meteorite. The Mosey meteorite from Tanzania has been staying underground for centuries before scientists gave it a proper look. The locals loved this space gem, calling it Commando. It was known in town for generations. Mosey is made of the same stuff as its other meteorite friends on Earth, about 90% iron and 8% nickel. It weighs 25 tons. Let's talk about the El Chaco meteorite, part of the Campo del Cielo meteorite crew in Argentina. Imagine an almost 24-square-mile playground for space rocks. El Chaco, weighing 37 tons, decided to show up fashionably late in 1969. So, what if you found a meteorite? How can you tell for sure that it's not just some random rock? These space visitors have a few features that make them stand out from regular rocks. Firstly, meteorites are often heavier than they look because they're packed with heavy metals and dense materials. Secondly, most meteorites have some metallic iron, so magnets usually stick to them. If you've got a rock that's not magnetic, try suspending the magnet from a string. The third clue lies in their unusual shapes. Iron-nickel meteorites aren't smooth and round. Stony meteorites usually have a thin, crispy crust on the outside. It looks as if their surface melted a bit while moving through the atmosphere. Sounds like pizza to me. Suppose these tips won't help on your quest. Then consider this. Light-colored crystals are not meteorites. Those pretty things, like quartz, are common on Earth, but they don't hang out on other planets or moons in our solar system. Do you know those bubbly holes in volcanic rocks or melted metal slag on Earth? Meteorites don't have those either. Plus, scratching a meteorite shouldn't leave a mark. But if you scratch a dense rock and get a dark or red mark, the rock contains minerals like magnetite or hematite, which meteorites don't usually have. If you suspect finding a meteor in your backyard or something, try these tips. Just remember, to be sure, you've got to give rocks and minerals a real-life look from experts. And if you see one falling towards you, always remember to duck. Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams lived long enough to tell us more about oceans past. Ancient mollusks could live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.